Okay, so we're going to do some work on percentages, ordinary percentages, percentage change, reverse percentages, and compound effects. So it says here the price of proteins increases from 45 to 47.50. What is the percentage increase? And give your answer to one decimal place. Okay, so a percent is equal to the change in the amount. Now that could be an increase or a decrease. Divide by the original amount times 100. Basically, I think of this as a fraction times 100 equals the percent. So the change in the amount is the 47.50 minus the 45, because that's the increase. And the original amount was £45. And we're going to times that by the 100. So we end up with £2.50 over £45 times 100. So £2.50 divided by 45 equals times 100. So 5.56%. I wanted to one decimal place, so 5.6%. Okay, so remember that I wanted to one decimal place. Alright, so again we go through and just make sure we've done everything we wanted. Yeah, we've done one decimal place, we've done a percentage increase, and we recognised it was going up £2.50. Okay, so that's a percentage change question. Eliza buys a car, 3 years later she sells it for, work out the percentage loss. Okay, so this will be again the idea of percent equals fraction times 100. So the fraction we've got, so Elizabeth buys a car for 12,500, 3 years later she sells it for that. So the change in the amount, which is what the fraction is on top, so it will be 12,500 take away 6,200. And the original amount was the 12,500. And we're going to times that by the 100. So I've got 12,500 take away 6,200 divide by 12,500 times 100. So 50.4%. And that's not unusual, guys, so get used to it. You buy a new car and virtually as soon as you drive it off the forecourt, you've usually lost around 20 to 25% of the value of the car. It's second hand, and cars do lose value quite quickly, so do think about that when you buy them. Okay, so that's percentage change again. Now there's another question here that she's invested 6,200, pays 3% interest per year. What is the value at the end of 2 years? Now they're not being clear here whether this is simple interest or compound interest, so we'll have to assume that because it says the word invest, then the assumption we make is that she leaves all the money in the account and then each year she's getting extra money, percent on percent. So technically it is a compound percent question without using the word compound. So at the end of the first year she's going to have 6,200 times 1.03. So 6,200 times 1.03, so 6,386. And at the end of the second year, she's going to have the amount that she had at the beginning of the second year times the percentage increase. So times that 1.03 again. So £6,577.58p. What is the value of an investment at the end of 2 years? Yep, so it's the value of the whole thing, so that's what the answer is. If you're not sure why it was times 1.03, then we need to remember that when you're doing percentages, quite often it's useful to do with most percentage multipliers. So the original is always 100%, but then you're increasing by 3% interest. Interest gets added on. So you end up at the end of the year with 103% of what you had at the beginning of the year, and that's equivalent to timesing by 1.03, because we turn a percentage into a multiplier by dividing by 100. Okay. Alright, so This question talks about a necklace. It's increased in value by 15% from its original price. It's now worth, what was the original price? Okay, so this is what's known as a reverse percentage, because you need to go back to the original value. So if you think of a little flow chart, then we had an original value. We increased by 15%, so we added 15% to its value, and it gave us an answer of £1,380, so it's new value. The question basically wants you to go back to what the original value was. Well, what we've got to remember is that if we add 15%, then that's the same as timesing by 1.15. Again, if you're not sure why, then the original percentage, in fact the original value is 100% of what it was. You're adding 15% on as extra value, so you end up with 115% at the end of the process, and that's equivalent to timesing by 1.15, called the percentage multiplier. Now the idea of the reverse percent is that we're going to reverse the process. So instead of times it by 1.15, we're going to divide by 1.15. So we get 1380 divided by 1.15, so £1,200. Now, with reverse percentage questions, I mean, you should check with all questions, but it's really important that you do check this one, because the classic mistake students make is they'll do 15% of 1380 and then just take it off. That is not how these kind of questions are done, because you've got to remember the original value is what the 15% was acting on, not the 1380. So the check is find 15% of 1200 and add it on. So 15% of 1200 is going to be, well, 10% is 120, plus another 60, that's 180, and 1200 plus 180 is 1380. Okay, so because it said that the original was increased by 15%, so I've taken what I think is the answer, I've found out 15% of it, I've added it on, and I've checked it gave me the 1380. So again, it's just worth checking the values. So the original value for this question was £1,200. Okay, so we've got a bank account and it pays compound interest at an annual rate of 4.7 for the first year, 4.2% for the second year. She invests £1,500, work out the total amount of money after the end of 2 years. Okay, so it's 4.7 at 4.2. Now, under the what do we know, then because this is about interest, it gets added on, then this is a percentage multiplier of 1.047, and this is a percentage multiplier of 1.042. Again, be careful with percentages that are decimals and things. Think of what's happening. You had 100% of your investment originally, you added on 4.7%, so that gave you 104.7% at the end of the year. And because we want a percentage multiplier, we divide by 100, hence the reason we get 1.047. So basically, at end of first year, we had £1,500 originally. We're increasing by 4.7%, so we're times it by 1.047 equals, so 1,500 times 1.047, so 15,750. Remember, it's money, so I always put that extra zero on there to make it 50p, 40p, and so forth. Okay, and end of second year, we now have the, because it's compounded, we now have the amount we had at the end of the first year, and we're increasing that by 1.042. So times by 1.042, so £1,636 and 46p. That's a 1, so that 6 stays as a 6. Okay, so that's the answer. In a sale, there's 45% off the price of everything for the last day of sales, a further 10%. Mrs. Mills says that this means a total of 55% off. Is she correct? Explain your answer. Okay. Well, if okay, so 55% off means 45% left to pay. So times original value by 0.45. Okay, so in a cell there is 45% off the price of everything. So the 45% off means we had 55% left, so we times by 0.55, followed by 10% off, which means we have 90% left of the 55% of the original value. So we end up doing 0.9 times 0.55. So 0.9 times 0.55, which gives 0.495. So 1 take away 0.495 equals take away 1, 0.505, which means end up with well, it's 50.5% off, not 55%. Okay, so let's go through the logic of this then, guys. So we know that if we take 55% off something, then it's left with 45% to pay. That's the same as times the original value by 0.45. What we're trying to show is that when we do the combined effects of what they're talking about in the question, the answer is not 0.45. 45% off, take away from 100, 55% left to pay. So we've times the original value by 0.55 at this stage. We then follow it with a 10% off, which means we've got 90% left to pay of what was the 55%. Multiply those multipliers, we ended up at 0.495. So we ended up paying 49.5% of the original price. So we ended up with a 50.5% off, and hence not the 55% the question was saying to. It says, is she correct? So we should say at the end here, no, Mrs. Anderson is not correct. It gives a 50.5% discount, not 55%. Okay, so that's how that question could have been done.